Ladies and gentlemen, we ask that you please take your seats at this time as the program will begin momentarily.
Data interpretation. Numbers tell the truth, or how to lie with statistics. So think about for a moment, what is it that you actually need to interpret data you find from your studies? There's the so-called term of statistical literacy, and of course there are a lot of conventions, but statistical literacy basically includes the ability to interpret and critically evaluate statistical information or data-related argumentation. And secondly, it includes the competence to discuss and communicate reactions to these arguments and the understanding thereof. So not only that you need to be able to read the statistics, but also to understand the logic behind it. There's a nice definition I have included in this slide, so that says statistical literacy is the ability to understand and critically evaluate statistical results that permeate daily life, coupled with the ability to appreciate the contributions that statistical thinking can make in public and private, professional and personal decisions. So this also additionally includes the component of decision making based on data. What is currently discussed a lot in evidence-informed decisions, evidence-informed policy, and so on. So I think developing this statistical literacy and also understanding the terminological conventions in statistics is really important. So just as a little exercise, think for yourself for a moment, what are statistics? Are they the aggregation of numbers and facts? Or are they methods of analyzing and making sense of data? I think most people would actually agree to that. Of course, it's much more that we need to use statistics as methods of analyzing and making sense of data than it's an aggregation of facts. You have learned that throughout the course in a lot of things, how to collect the data, how your samples are taken. So there are a lot of dependencies on how statistics shape the conclusions, and you can do a lot of mistakes, of course, there. So what do you actually need, and what should you take care of when you start to read your data and interpret your data? First, but very important, start simple. Use the power of descriptive statistics and try to get a grasp on what is in your data set. And be aware on the type of data that you have collected and what conclusions are okay or are allowed based on that data you collected. I come to the different data levels in a moment. Second, use, based on these simple statistics, also instruments as crosstabs or related variables. Think about other components you probably not have taken into account and that might have influenced your outcome. So relate your data analysis and relate the results you find in the descriptives to your hypothesis, and very important also to your conceptual model, as it's just one instance of a more general model you have, and you should try to see if there are the relations you expect. And only then, and also of course related to your concrete hypothesis, apply inferential statistics on the appropriate data level and be aware about the concept of significance testing, consider power and the effect size you're looking at. And I come to these concepts now in this presentation. So what data is collected? We talked about different methods of data collection. But let's look at when you come to the step how you encode this data and what is valid to conclude from these different data levels. You basically have 4 data levels: nominal, ordinal, interval, and ratio level. You see some examples. Typical nominal data is you collect the age or the gender. Age you typically categorize in different classifications that appear relevant. But of course, for the gender, you cannot compute, and you should not try to compute an average. But you would take the mode or the modus and calculate the higher number, or you describe the percentage and the distribution. That is what you typically do. On the ordinal level, you get a ranking of the data. So you can use all kinds of ranking statistics. You can also do tests on that level, hypothesis testing, but you need special algorithms on that level. And of course, you can choose a median with ordinal data to find about, okay, where roughly in my distribution of ordinal data is my split point, so to say, 50-50 split point. The interval data, that is what we find mostly. So IQ scores are calculated on that, temperatures, and there you can already use the full range of descriptive statistics, mode, median, standard deviation. And important here, the difference becomes meaningful. So you can also transpose and transfer your data sets based on that. And the highest level then is the ratio, and the special issue here, or the special point is here, that you have an absolute zero. That means you also can do multiplication as a transformation operation. So, but based on that, look at the descriptive statistics you can use. You should be very clear what kind of descriptive statistics you use. Then one word about crosstabs. I find this a very powerful instrument. Basically tables where you bring together 2 variables and their descriptives, or you split a variable based on a nominal variable. So looking, for example, at the means and average values, split it by gender, split it by age, and so on. So contingency tables or simple crosstabs help you to understand your data set. If you find some interesting hypothesis there, if you do more kind of explorative data analysis, you also have instruments to do hypothesis testing on this, or significance testing. And so important here, look at the distribution of this. I think this gives you a very good idea also of outliers, of distributions across specific nominal variables. Probably one remark here about chi-square is that, of course, this is a test that basically looks at the difference of expectations and actual values in your data set. And I think this is nice to see, also to get a first idea of, is there anything special about this data set? So now, what can be inferred based on the data you have collected? Assumed you have the right data level, assumed you have the constraints are fulfilled. Based on the tests you apply, what kind of conclusions can you take? So I just take some examples here. For example, based on an R value coming out of different forms of regressions, you can conclude, is there a relationship? How strong is this relationship? And in which direction is it going? A T or a t-test, basically you compare 2 groups. So the only thing you can say is if there is a difference between the 2 groups based on your probability level, and I come to that in a minute. And the same basically for an F value or for an ANOVA. So is there a difference between the 3 or multiple groups based on your probability level and your alpha level? So I come to significance testing here in a minute. Of course, what is significant? First of all, be very precise in the language you use. you come to that basically based on the alpha level or the error level in null hypothesis testing. You have to say either significant or statistically significant or highly significant on the 1% level. So now one aspect, if you read an article or if you have to report your own results, be aware of what significance testing actually means and the underlying assumptions. Just to give you one illustration, on the right side you see a little table, and basically this here shows, based on my number of participants on my cases, on what level do I need to have find a difference, or how strong should the relation be based on the number of cases to find a significant relationship. So what this clearly tells you, or should tell you, is that the significance and to find a significant difference or a significant relation depends on the sample size. And this is an important issue you have to take into account. So a lot of more recent literature looks into that. You, of course, and also the current literature from the American Psychological Association says basically you should and you need to also report the effect size. So, but back to the basics, what does it mean if you test for significance? Basically, let's say you take an alpha level of 5%. You take a 5% chance that you might do a mistake. So in the so-called type 1 error, you then you reject the null hypothesis, but you should have kept it. So there's a 5% chance for that. In the type 2 error, you basically have a miss. You accept the null hypothesis, but actually there is a difference. So in that sense, the 5% level or the 1% level you choose, I mean, that's a kind of artificial split point, but that of course is a convention. So in some cases, and in most cases, you really have to look at the content itself and at the decision you take, and not simply apply that without thinking about the consequences and the content-wise conclusions you make. So what is it actually now when we talk about the effect size? Simply taken, but this is a topic you really should look into if you seriously want to report statistical and inferential statistic results. So the effect size is a measure of how big the effect difference is actually between your groups when you do, for example, a t-test. And there's are different ways to calculate it. Typically, it's differentiated into small, medium, or large effects. But this means basically how strong is this effect. And be careful with the effect. It's not a causal relationship, but how strong is this relationship? And you have to take into account, when you do significance testing, these ideas about assumptions of accepting the null hypothesis, your significance level, the power of your test, so the statistical power, and the effect size. And there are different ways to look into that, but this would extend also the part here. You find a lot of materials in the additional readings. So to sum up, look at the descriptive statistics to understand the basics of your sample and your assumptions and the relation to your hypothesis. When using null hypothesis statistical significant testing, take into account the sample size, the sampling strategy, your effect size, your statistical power. And infer only what you can link to your data. Beware of the difference between results, when you report results, and your interpretation of these results. Be aware of the concept of significance testing, the effect size, and the difference between causation and correlation. Thank you.